Alrighty, moving on to the next topic here, we're going to look at section 2.7 from the book called Percent of Change. This is looking at when you increase or decrease a number by how much the percent difference you have. Percent increase would be, well, I'll get to it. So here we go. Vocab first. Percent of change. What is the definition? It's the ratio of a change in an amount to the original amount as a percent. So it's basically like a percent increase or percent decrease. Percent of change is the overall word that means either percent increase or percent decrease. But typically you won't really talk about percent of change. You'll talk about a percent increase if it's going up. If the answer is positive, you're increasing your value. And you'll talk about a percent decrease if the percent of change is negative, which means your price decreased or your value decreased. So really we'll talk mostly percent increase and percent decrease, but collectively together those are called a percent of change. Okay, so make sure you write this down. Moving on. Percent of change equation. So we can calculate the amount that the quantity changes, by what percent it changes, by using the following formula here. So you take your new value, or your final answer, you subtract the old or original value, then you divide by the old or original value. That'll give you a fraction, okay? And then you multiply by 100% to convert that fraction or decimal into a percentage. Okay, if you rearrange this equation, say you know the old value and you know by what percent it changed and you want to find out its new value, then you can rearrange this equation and you can obtain this equation down here. So it's really just the same concept, just rearranged. So it's not a new equation, it's a different form. That's why I called it here alternate form. It's not a different equation. It's the same equation rearranged. And we'll learn how to rearrange equations like this and turn them into equations that look like this in the coming weeks. That's one of our biggest topics, is rearranging equations and solving for a particular variable. So if you're trying to find the percent change, it's best to use it in this top form. If you know the percent change and you're trying to find the new or old value, this form is the best one to use. And we'll do some examples momentarily where we use these two equations. But for now, make sure you copy these two down. Okay. So problem solving tips. What are the things that you want to keep track of when you're solving percent of change problems? The first is that anything that talks about a discount or a coupon is going to act as a percent decrease. The price will go down. And tax, among many other things, all act as percent increases. But if they just mention there was a discount or there was tax, or maybe even here we could add in a coupon, they won't explicitly tell you that it's a percent increase or decrease. You just need to know that these are decreases, tax and other things are an increase. So let's do some examples. Find whatever it asks you for. Percent change, old price, or new price. So given that you want to buy an iPhone for $199, but you've got a 20% coupon, what's the final price? So we're trying to find the new price. We know the old price here, and we know the percent of change, 20% change. So we can write new equals old times, let's look back at our formula so we can help remember. New equals old times 1 plus percent change out of 100. 1 plus the percent change goes here out of 100. So the percent change was a 20% coupon. Well, remember a coupon is a decrease, so we'll put in here negative 20. Okay? So this is going to be new price equals old price, which was $199, times 1 plus 20 divided by 100 is 0.2, but we're subtracting it, right? Negative 0.2. So we have that the new price is $199 times 1 plus a negative 0.2 is the same as 1 minus 0.2, which is 0.8. So our final answer here, if I grab a calculator real quick and I type in 199 times 0.8, I get $159.20. Okay, so that would be the price of your iPhone. Let's look again at this equation though and see if maybe there's an easier way to visualize it that will make us have to write down a little bit less. If I got a 20% discount, it should make sense to you that means I only had to pay for 80% of the total price, 20% less than 100%. So that's why this equation is what it is. 1 plus the percent change. The 1 stands for 100% of the price, and then the percent change adjusts that either up or down. So if you know it's a 20% discount, you could probably jump straight to here. without writing down these first two steps, because you know that if you subtract 20%, you're going to be paying 80%, and 80% as a decimal is 0.8. So you only have to pay 80% of the purchase price. You can jump straight to here. So in this formula, you might write this formula as new equals old times percent actually paid, right? So if you have tax, you have to pay an increase. If you have a coupon, you pay less, but it's the percent actually paid, and we have to write this as a decimal. That's very important, right? As a decimal. Alright, so that's the same formula, just a different kind of way of visualizing it. Alright, let's move on to the next couple of examples. Suppose you paid $82.52 for some new clothes after the 8% tax was added. What was the price of the clothes before tax? Okay, so one way to do this is to use the second equation. Remember, new equals old times actual. I'll just put actual percent, and you have to remember that we're converting that to a decimal. Okay, the new price is what we paid here, 82.52. The old price, what was the price of the clothes before tax? That's what we're trying to find. So we leave that as an unknown. And the actual amount we paid. If there was 8% tax, yeah, that means we paid an increase. We paid 108%, or 1.08 times the purchase price. The 1 stands for 100%, and the 0.08 stands for the 8% increase in tax. So how do we solve this equation for old? Pretty easy. We divide by 1.08, and if we follow the golden rule, whatever we do on the right, we also do on the left. On this side, they cancel out, so we know that the old price. And another thing you can do is just common sense wise, the price before tax has to be less. So if you accidentally get this upside down or something, you'll know because the price won't be less. Divided by, so I'm typing in my calculator, 82.52 divided by 1.08, and I obtain $76.41. So the price before tax, $76.41. After tax, it went up to $82.52. So this common sense makes sense because this price went up after tax. Alright, last one. A $28 soccer ball is on sale for just $18. What is the percent discount offered? Now in this case, let me zoom back to our equations. We're asking what was the percent discount? What was the percent change? So this top equation is a lot better one to use. Okay, so the formula was the new price minus the old price divided by the old price. So new minus old tells us what the actual discount was. Then we compare that to the original, and then we multiply by 100. So new minus old is 28 minus 18 divided by the old price, which is $28. Then times 100. This 28 minus 18 tells us we got a $10 savings off of a $28 item, and then we convert it to a percent by multiplying by 100%. So 10 divided by 28 is 0.357 blah 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 times 100 is 35.7, and I'll just round to the tenths place here, percent discount. Okay. And it turns out, interestingly enough, that there is a small mistake I just noticed. I want you to see if you can find it. So maybe pause the video, look very carefully at my math right here, and see if you can find the small mistake. Okay, here, I'll point it out for you. I got a percent discount, yeah? But my answer wasn't negative. A discount is supposed to be negative. If I get a positive out, that means it was an increase. So my formula says new minus old. What was the new price of the soccer ball? The new price was just $18. So here, I should have had 18 minus 28 divided by the old price, which was 28, which would give me negative 10 over 28. So the percent will come out to be the same. It'll still be 35.7, but it will be negative, and that's how I knew that it was a discount. So I'm glad I made that mistake for the following reason. A lot of times common sense can save you from getting a math problem wrong. I knew by reading this problem that there was going to be a discount, right? So the fact that I missed my minus sign, that I got these two backwards, it didn't make me get the problem wrong because I understood the idea behind whatever the math was telling me. If I was just blindly plugging in numbers without understanding where they came from, then there's a higher chance for me to get it wrong. So always think about the common sense of what you're doing, and sometimes that'll help you. Even if you make a math mistake, it'll help you kind of uncover it and see what it is. Okay, so we'll see you in class.